Alright, hello, welcome back to episode 2 of the Arduino Quick Setup Guide. I'm Matthew and this is Aaron, and we're here at the Visual World Investigate Lab, part of the North Carolina Museum of Natural Sciences in downtown Raleigh, here to teach you about how to use one of our favorite little devices in Arduino Uno. In the first episode, we told you all about what this is, how it's a cheap little circuit board that you can use to make almost anything that you can think of with a little bit of code and a little bit of electronics. Now, we're assuming you've never used one of these before, and maybe never have even done computer programming before. And that's okay, because we're going to show you step by step how you can use these to start making whatever you can think of. Now, again, in the first episode, we showed you how to use this just a little bit, how to attach an LED, how to get an LED to light on it, and how to write some code and send it to it. In this episode, we're going to show you how to add an external LED to it with some wires and some circuitry, and then we're going to show you how to add a button to it as well to get it to do whatever you want. So, Aaron.
Yes, so if you'll remember, last time we built a blink sketch, and hopefully you still have that on your Arduino. So I'm going to show you some components we're going to use to build a physical circuit version of that using a larger LED. So let's first start off by talking about breadboards. Not the type of breadboards you may be thinking of. These breadboards, they look like this. We also have some zoomed in right here. So if you'll look here on the left, we have the front of a breadboard, and on the back we have an opened, the back side of the breadboard. It normally has some type of foam on the back to cover it up, but here it has it exposed so you can see how these work and how they connect, because they can be kind of magical, mystical, elusive, but they're pretty simple. So the breadboards, you'll notice there are rows and columns. So let's first talk about the sides here. So on this breadboard, you'll see there's a negative and a positive row or column up and down on both sides. And what's going on there, those are fully connected. So if you look here at the bare side, you will see a piece of metal running all the way up and down those columns. And so that means that if you connect something at the top in one of those columns, and you could connect anywhere else, even all the way at the bottom, those will be connected together. The other thing that works, you'll notice these rows here are connected with a divider in the middle. So when we look at the top of our breadboard, you see the divider in the middle, and then you see rows on each side. So you can think about these, they're numbered here for us, like 1 through all the way 30 on this one, and then you have letters going across. So here, 1A through 1E are connected. So on this breadboard, it would be like here to here, and you can see that's all connected by metal. The same on the other side, connected by metal. And if you have a smaller breadboard, you can see this one here and this one here, very similar. You just have the rows here, you don't have the columns on the end. And you may be wondering, what are all these little metal parts here, and what do they look like? Well, here is an up-close feature of that metal piece. And you may notice on this that it just has individual little pins here. So you can imagine this being connected underneath. So each of those little pinholes has that little piece of metal there, and it clamps onto the wire for you temporarily, which is why breadboards are nice for prototyping and building things that aren't permanent. But that's what it looks like on the inside. So hopefully that gives you a better idea of how to use a breadboard. So let's move on to our next component. This is going to be a resistor. And I'm not sure how much we've talked about resistors so far, but if you've never seen one of these, it's a little pill-like looking feature with 2 wire legs on each side. And you'll notice on this that it has a number of bands. And those bands are different colors that tell you the value of the resistor. And you can look that up using a resistor guide that likely came with your resistor book. You should have had some of these in your kit, and it should tell you what they are, what they look like. You can also even use a multimeter to figure out the resistance in one of these. And that's a very advanced feature that we won't do here today, but you can look it up and figure it out on your own if you're interested in that. So here's a resistor, and what these do is they resist electricity, just like the name implies. So if we had this connected to a circuit, electricity is coming from one side of it, goes all the way up to the resistor. The resistor resists some of that electricity, so you have less electricity going out the other side, which can be very useful in electronics because that can let you get the proper voltage to certain components. And today we'll be using this to get the right electricity, the right voltage going to our LED. Speaking of LED, there's a lot of different LEDs out there. So we have right here a very common red LED, which you can see up close. I also have a very large, another LED, and an RGB LED that I will talk about a little later. So let's look at this red LED up close. So you'll notice there are two legs coming out the bottom. One of these legs is longer than the other leg, which is important because this LED stands for light emitting diode, which means electricity can only flow one way through that circuit. So here, this longer leg would be hooked up to the live or positive part of the circuit, and the shorter leg would be hooked up to the negative or the ground part of the circuit. And up here at the top, this little red case has the diode inside of that. It's kind of hard to see on this one, but trust me, there's a diode in there, and it'll light up whenever electricity runs the proper way through that. And I mentioned that there's an RGB LED, so I'm going to set this right here next to it, and you can notice that it has 4 legs there. And the reason it has 4 legs, it's just like the red LED, except you have another pin for a blue and for a green light. And you can combine those together in any color combination you can think of. And that's a fun future project for you. If you're interested in these, you have one of these, you can test it out. Just like we did the one red LED, you would do that 3 times and control each color independently. So that's our LEDs. Now, let's build a circuit for our blink sketch. So to get started, you would pull out your Arduino and your breadboard. And then we're going to need a few components that we just talked about. So I'm going to start by connecting my wires and getting ready for my LED. So the first wire I'm going to do is I'm going to pull out a ground wire. So here, we kind of use black often to indicate ground. So to build this circuit, I'm going to use my Arduino. Switch this up here so you can see it a little easier. So right here, ground or GND on the Arduino port. So I'm going to put this black wire into that, and then I'm going to attach this black wire to one of the rows on my breadboard. Hopefully you can see that there. Next, I'm going to grab one of my resistors. I think this is a 330 ohm resistor, about that. You don't need a lot of resistance, but this will make your LED very dim. So if you grab a very strong resistor, you might barely see the light in it. So taking this resistor, I'm going to go in the same row as this black wire with one of the legs of the resistor. And then the other leg of the resistor, I'm going to move on down a few other rows there. So I've got my resistor in there. So the next part, I'm going to take my LED. And remember with the LED that I said the short leg goes to ground, the long leg goes to positive. So here, the short leg, I'm going to put that on the same row as my resistor. And then the long leg is going to go a couple rows down. So it's not connected together. So the last piece, we need one more wire. Here I'm going to use a red wire. We typically, in electronics, use red or white or some kind of bright color like this to indicate the live or the positive part of the circuit. So I'm going to take one end of this and connect it to the same row as the long leg of my LED. Get that in there. And then I'm going to take the other leg and connect it up to the pin number 13. Because if you remember, we told it to light up the LED on pin number 13. And 13 is right here next to this ground pin. Connect that in, connect that up. And now I'm going to plug it in, give it power to the circuit, and hopefully it works. You can now see the light on the board and the light on the Arduino working. So you have the light on the board and the Arduino. And if your Arduino is not working, you can retrace the circuit, make sure you got everything in place. And if it's still not working, check to make sure the legs are in the proper way. You may have it in backwards. It just won't light up. So let me go through this one more time for you. I'm going to get a better view here so you can see up close what the circuit looks like. Like this. Let's go. Right, there's a little better view there, I think, for you. So notice in the ground pin of the Arduino, we have a wire that goes over to one row on our breadboard. Connected to that is a resistor, one pin of that. That resistor then goes over to a separate row down here that is connected to the short leg of the LED. The other leg of the LED is in another row. And it's important here to be in different rows because you remember the rows are connected together all the way across. So the other leg of the LEDs there, the long leg, and that's connected to this red wire that's connected to pin number 13 on the Arduino. So if we were following the electricity, it would go all the way through the circuit just like that, and when it's completed, it lights up. So that's our LED circuit. Hopefully you were able to get this working, and you should already have the code from the last video. If you don't have the code for this, go back, watch it again, come back to this spot. So next we're going to talk about some basic sensors and some buttons. Buttons are one of my favorite things to use in electronics. So Matthew, take it away.
All right, so buttons. Everyone likes buttons, and we are going to use some today. The kit that you purchased would have most surely come with some buttons. We're going to use the most common one. So let me make some space over here and show you all the button that we're going to be using. This is a very typical momentary push button. That means that unlike some kind of toggle button, this button won't stay pushed down. You push it and then you let go and it pops back up. So the way that these work is that you send electricity through one of their legs, and then it sits there. It can't go anywhere because there are some metal pieces inside that are like this. And it's only when you press the button that they actually make contact. And once they make contact, then that allows the electricity to flow through to other legs on the button. And so on the underside here, these are the legs that I'm referring to. Now this type of button is designed to be simple to attach to a circuit board, but it's also designed so that it attaches very easily to a breadboard. So let me show you how to do that. You can take any of your breadboards that you have. I'm going to take one of these little ones here, and I'm going to put it right here in the middle. I'm going to the width of this little divider part is perfect for placing the button, just like this. I'm going to push it down nice and firmly so that there are two legs on one side and then two legs on the other side. And it's grabbing into the metal inside the breadboard, so it's going to stay there nice and tight. Yeah. All right. So let's work out that circuit first, and then we'll move on to the code. And we'll continue on.
I think one of the fun things about these little buttons is that they're in basically every electronic device that you have probably ever seen. Like think about buttons on a TV, under the plastic little features there, there'll be one of these, and it'll look exactly like this. Like I could have taken that from the TV over there and you wouldn't know it. Same button.
That's right. Yes, I've found them many times. So we need some wires and we need a resistor. We'll need 3 wires and a resistor. Let's begin with adding power to the board and power to the button. We'll do that by grabbing a wire. Let's go with a red or a white because this is going to be like the hot wire, the wire that the electricity is starting with, just like what Aaron said. And then we also need a resistor. So in your resistor pack, you probably have a 10K ohm resistor. That refers to how much electricity it's impeding. If you don't, you get as close as you can to that. But this is what the 10Ks usually look like here. I'll zoom in on it. The color codes may be a little different from everyone, but I've got brown, black, orange, and gold. So we're going to have electricity first go through that resistor and then on to the actually the resistor is going to be connected to ground. I apologize. We're going to use the resistor a little bit later. We're going to connect the red wire to one of the voltage outputs on the Arduino. So the Arduino actually has two pinholes that supply a constant voltage output. They are on this side over here. There is one that, here, I'll zoom in here for you. There is one that says 5 volts and one that says 3.3 volts. And that's because a lot of parts, especially a lot of sensors, operate either at 5 volts or 3.3. So it's very convenient. We're going to attach our live wire to 3.3 volts. All right, and then you'll notice that the other leg of the wire I have attached, let me zoom out for you. The other leg of the wire I have attached to the same row as one of the legs on the button. Doesn't matter which one yet. To begin with, you can pick whichever you would like. All right, now we have power going to the button. Now let's go ahead and go back to our resistor, because we need to connect a ground wire so the electricity can flow back to the Arduino to complete a circuit, but we want to go through a resistor first. So on the same side as that power wire, but on a different leg, we're going to attach a resistor. All right, and then the other leg of that resistor is simply going to attach to any other row on the breadboard, a row that nothing else is in. Okay, so we've got leg of the button leg right here, and in that same row is a leg from one of the legs of the resistor. And then the other leg is just over here now. So in this row where the other leg is, that's where we're going to want to attach our ground wire. So go ahead and grab a black one, because that's what's always used for ground. The wires are actually the same. The colors are just to help you stay organized. And then connect the other end of the wire to any of the 3 grounds on the Arduino Uno. So just look for a pinhole that says G and D. All right, so that's good. Okay, so now the last thing is we need a signal wire. We need one more wire that'll go from the button to one of the digital inputs on the Arduino. We're going to pick digital input number 2 because that's what we're going to enter into our code later. And the pin that we choose for this is important. We want it to be diagonal from the power pin. So this pin here on this pin here on the button is the one that the power is being supplied to. Diagonal from it on the other side of the board is where we want to put the signal wire. So right there. And then the other end of that signal wire is going to go to digital pin 2 on the Arduino. Okay, so now the circuit is complete. Let me show you how this works one more time here. So electricity is going to start at the red wire, which is connected to 3.3 volts. It is going to travel down to the breadboard to this row here, and only this row. And connected to this row is one leg of the button. It's going to travel through the button, and then once the button is pressed, it's going to be able to go to, it's going to go to 2 different places. One, once the button is pressed, it's going to be able to go to this signal wire, the orange wire here, which is diagonally across from the power pin over here, power wire over here. And this goes to pin 2 on the Arduino. You could pick a different one, but that's what we're going to use because we're going to enter that in our code. On the same side as the power pin, the other pin is going to have the 10K resistor attached to it. One leg of the resistor is going to be attached to that row with that pin. The other leg is attached to simply a different row. And then finally, it's attached to that same row is the ground wire. So this is going to take electricity back to the Arduino to ground so that it can travel in a circle like it likes to complete a circuit. So that's the flow of the electrons inside of that. Now, let's move on to the code. All right, so your Arduino IDE, which you should have installed, and we went over in episode 1, which you should go back to if you haven't, The Arduino IDE is where we're going to type in our code and then send it to the Arduino. When you first load it up, it's going to look just like this. It's going to have some like starter code in it, typical functions that it assumes you're going to use. Let's just go ahead and delete all of that. All right, and start from scratch. Now, you'll recognize some of the things that we did last time, but we're going to do a lot of new things as well. This time, instead of just one variable at the beginning, we're going to have 3. So let's start with one we used before. We want our button when we press it to turn on an LED, so let's make a variable for LED. int LED. int is a type of variable, and LED is what I'm naming the variable. int LED equals, and I'm going to pick 13 because the LED that's built into the Arduino is tied to pin 13. So this way I can just use the LED that's on the board and I don't have to hook up an external LED. You can do that if you'd like. Semicolon to end that line. Now the next variable will be for the button. So we just have one button, so let's just call it button and set that equal to 2. That's where we've attached our orange signal wire. All right, for the third variable, this is where it gets a little bit fancy. We'll use int again and then call this variable button state. And what I mean by this is the state of the button, because the button is going to exist in 2 different states, either going to be high or low, which is the same as saying on or off, or 0 and 1, again, on or off. But we're not going to set it to we don't need to set it to represent anything because it's going to be constantly changing in the code. All right, now our first function here is going to be the setup, as it always is. Type out void setup, and then open parentheses, close parentheses, and then open curly brackets, and then enter. Now, you see it automatically put that closed curly bracket there. That's good. I want to be between them and put all my setup code between those curly brackets, or else it's going to get confused, because again, it uses them to know where the setup code starts and where it ends. Now, you'll remember from before when we did this, we had to set the pin mode for the LED. Well, we need to do that again, but we'll also need to do it for the button as well. So let's start with the LED pin mode. Open parentheses, and then expects 2 different parameters. First is the pin that you're talking about. The pin is, we can just use the variable LED, the name LED, comma, and then you have the option of either setting the mode to be input or output. We want to light up an LED, so we want it to be an output. We want to output electricity. It's got to be all caps, which is always fun. All right, so now let's do one more pin mode for the button. So for this one, button, and then comma, and then instead of output, as you probably guessed, we want it to be input, because we want it to detect the presence or absence of electricity. We want it to read that. So input, again, all caps. So if your caps button still works, please use it. And then we're done with the setup. So I'm just going to use the arrow key to go past that curly bracket because that's done. I don't want to put anything else in there. And now we'll enter the last function, which is the real brains of the code, the loop. This is a chunk of code that will be read and executed by the Arduino from beginning to end, and then when it gets to the end, it's going to go back to the beginning again. So that it just doesn't detect the button just for a split millisecond, and then that's it. Now it'll detect it over and over and over. All right, so parentheses, open curly bracket, enter. I'm going to hit enter one more time just to things don't get too close together. And now the very first line is very important. The very first line is going to be the line where the detection actually takes place. So you remember the last variable we wrote up there is called button state. So we want button state to equal, whatever the current state of the button is. So for that, we use, instead of digital write this time, like what we use to light up an LED, we want digital read. You can see it changed the color there because it recognized it. Digital read, and then digital read what? Well, it's going to expect a parameter here. It expects a pin number. The pin number we saved under the variable button. So, digital read button. Button state equals digital read button. So now, if the button is pressed, it's going to save button state as high. If it's not pressed, it's going to save it as low. Now, for the last bit of code for this program, we need to do one of my favorite statements, the if statement. The if statement is extremely powerful. Basically, all programs can be reduced to a bunch of if statements. It's like a test. If something, then do something else. So in this case, we're going to type out if, and then parentheses, enter the test, if button state equals high. Now, I didn't mistype that. I actually do need two equal signs here because that's how the language knows that you don't actually want something to equal something else. You're asking if it equals something. If I wanted it to equal something, then I would just use a single equal sign. So if button state equals high, close parentheses, open curly bracket again. You're going to be using that curly bracket a lot, so you're going to have to get used to it. Now, what do we do? If it's high, what do you want it to do? We want it to turn on the LED. So we've done this before. Digital write, parentheses, LED, comma, high, semicolon. And then that's all we want it to do if it's pressed. So I'm going to skip down here. Here's that close curly bracket for that if statement. That's good. I'm going to leave it there. And if it's high, turn on the LED. But if it's not high, we want to do something else. So here is where we go from if to else. Else, which is like saying otherwise, else, I'm going to hit enter, digital write LED low. Okay, so if button state equals high, turn on the LED. Else, which is like saying otherwise, turn off the LED. Now, I haven't had to manually enter a single closing curly bracket because it does it every time, and I'm just careful that I put the code where it's supposed to be between the curly brackets. And I can check to make sure everything's in the right place and I have enough matching ones by clicking next to one. When you click next to one, it'll show you where its mate is. So like for the contents of this else statement, I've got these curly brackets between. Well, are they actually paired? If I click here, it highlights that one, so I know they're paired, and that's good. So what's this one down here? Well, let's click on it, and I see that it pairs up at the with the one at the top here. That's good. And the last one was over here for the start of this if statement, for if it's true or not. That pairs with that. That's good, encapsulating that digital right there. So all my curly brackets look good to me. That should be it for my code. So I'm going to go ahead and plug my Arduino into my computer. All right, and then I'm going to double check. I'm going to go to Tools here to make sure that it's selecting the right port. Yes, it sees the Arduino, and it's checked there, so that's good. And now I'm going to hit the Upload button. And since I'm doing this for the first time for this sketch, it's going to ask me if I want to save it. I'll just leave that the same. You could change it if you want to. I'm going to click Save. And now it's checking it. If there are any problems with it, it's going to give me some orange error messages down here with some ideas, some hints as to what the actual problems may be and what line numbers they're on. But everything's good. I'll get some white text here, some confirmation that says like how much space is left on the board and whatnot. So now it's compiling it. It's turning it into the ones and zeros that the Arduino is going to recognize, and then it's going to start uploading it. At which point you'll see the buttons flashing. There we go. So the transmit and receive buttons started flashing, so it's on there now. I didn't get any errors, so now I can test it. So if I press this little button here, it lights up, as you can see over here. It lights up that little LED. Every time I press it, when I release, the light turns off. Now this is a really complicated way to make a light turn on. I mean, I could make this light turn on with a battery, a resistor, and the button and some wires only. You do not need a microcontroller. But this is just to teach you how to accomplish the same thing with code. Because again, the button is a very simple sensor. And there are lots of different types of really cool, sophisticated sensors that you can get into. And they work, and you use them in a very similar way because they're all just sending voltages back to the Arduino, and you would read it in a similar way to the way we're reading them now. Just use a slightly different pin in those cases. But that's it. So here we've made an LED blink. We've gotten it to the Arduino to do something in the real world. We've added a button, an input, that acts like it's a very simple sensor. So now we can actually interact with the Arduino. From here on out, there's a whole lot more that we can do. In the next episodes, we're going to be working on motors, and we're going to be working with servos, adding more parts, all culminating in a larger final project at the end. So, with that, thank you very much for watching. We hope you enjoyed this, and look forward to episode 3, where we get into using some more parts to get even further and further into how to learn how to use an Arduino and how to make whatever you might want to make. Thank you very much from the North Carolina Museum of Natural Sciences Visual World Investigate Lab. Have a good day.